Okay. All right. So I'm going to present Brimble Internals. Right. So basically, I'm just going to give a let's say a technical dive right to how we're able to build something like this. My name is David. A software engineer. I'm a co-founder to Brimble, and yeah. So let's get right to it. I have a fair share of experience in building platform as a service solution, right? And in my spare time, I play chess. I play a good number of chess. I enjoy gaming, and I'm a Chelsea fan. And when I'm not watching football or coding, yeah, I watch movies and animes too. Yes. I'm going to just put in a few things out there for this talk. Firstly, the origin story, the build pipeline, how we use Stack, basically the entire HashiCorp ecosystem. Um, Also, other learnings and bonuses, technical challenges we faced, and future rollouts that we intend to give out to users in the future. Yes, what's we're not going to cover? Buying domains. I don't really think there's a lot of technical detail to that. Also, custom DNS implementation. It's a different conversation. Also, deploying MCP servers on Brimble. So I won't be going. I'm not going to cover these parts. The origin story. We most of what we came out with were very heavily inspired by Verso at the initial phase. So I and my colleague Abraham, we were both computer science students, right, in school, and we built something like this together. That was starting in 2021, I think. Yeah, as a side project, it wasn't something really meant to be serious. So the general idea was just to find a very good and efficient way for us to be able to deploy Next.js application because at that time, Vercel was the only frontier in presenting um, Next.js applications, right? There were no other providers that could do it efficiently. Netlify could take like a long amount of time to deploy a Next.js application. All right. So the first version of Brimble was a CLI, was mostly a CLI, right? That was inspired by Surge. I don't know if we're aware of Surge. So Surge is just a CLI where you can just you install it and you deploy your application. So the first version, what it did was that the build runs locally on your system, and we upload the build output right to an S3 bucket. Then we save the contents from an S3 bucket. Then after that, we reiterated like over a lot of things, and we continue to pursue the best practices, also look at some pitfalls, and also how we can efficiently manage costs, right? Let's dive into other details aside the origin story. So actually, what happens when you build your project, or like before you build your project? You are working on a project, you push your code, right? And the way it works is that we have a webhook infrastructure right in front of our service that just receives webhook from GitHub, GitLab, Bitbucket, right? Any of the Git system that you integrate with Brimble, right? And the reason is because we don't want to lose webhooks. So systems like Convoy and HookDeck are very, very favorable for this. But at Brimble, we use HookDeck. So HookDeck is a webhook infrastructure system, right? Where you can always replay webhooks. You don't miss webhooks, right? And we have something internally where we used to detect frameworks. So let's say you want to deploy a Golang project, you want to deploy a Spring Boot Java, Next.js, yeah, just the typical things, right? We have something that you can use to detect the framework, then build container image and deploy. So this is just a very high level overview of each steps, right? And I'll be taking each steps like as it goes. So our core infrastructure runs on HashiCorp, right? So we use HashiCorp Nomad to deploy users' workload, right? So HashiCorp Nomad is I would say a growing orchestration system like Kubernetes, right? The Kubernetes ecosystem is very large. I think it's widely known. So we decided to go with HashiCorp Nomad, right, and Console to handle service discovery. So what do I mean by service discovery? So service discovery is a concept where you have a bunch of applications deployed and you need some sort of way you want those applications to talk to each other, or you want some sort of external source to reach out to it, right? So service discovery is just a way for you to discover services actually, right? So you want to be able to identify services that are deployed in your private environment securely, fast, and also efficient, right? And we also use vaults, Ashiko vaults, to manage secrets, right? Maybe your EMV that you deploy, right, with your project on Brimble. So your AMVs are not exposed publicly, right? So they are very, very encrypted. At the point of when you make the request to the backend server to deploy your application, right? We're not aware of the EMV, so they're automatically encrypted, right? Then we have it in Vault. So Vault manages the whole encryption lifecycle and injecting the secrets into the container. So yeah, I've gotten a lot of questions like regarding this, why we didn't use K8. One of the first few versions of Kubernetes, sorry, of no of Brimble actually ran on K3s. It's a smaller version of K8, but we realized something. I had a fair share of experience, right, using Kubernetes, but other members of the team um, didn't really have that experience, and even my experience with Kate isn't really that large, right? But we already had something with Nomad, right? We're building things around Nomad even before we decided to dive into Kate, right? So it was a very good option for us to just use Nomad, right? Because first of all, it's very easy to use and there's no much operational overhead compared to using Kate, right? It's a single binary usage. You don't need to set up like a couple of things here and there, right? So it's just a single binary you just install, ensuring your system meets the expected requirements. You should be good to go. So the architecture, I have a bunch of diagrams, right, in my presentation, and I prefer to explain the diagrams, right, rather than just like reading the text. So I have like about 4 to 5 diagrams, and I'll be explaining that very, very critically, right? So this is a very high level diagram that just shows how like services and how we deploy your projects, right? So the developer pushes the code, right? There's a build system, then we push the image to the container registry. Then the normal scheduler picks the image, right, and deploys it to the cluster, right? So let's say you want to replicate the container, right, or it's just single independent number of containers, right? And at the request phase, the user makes a request to the HCDN. So currently for our HCDN, we use Cloudflare, right? So Cloudflare sits in front of every of our load balancers that we have. And our load balancer is able to securely communicate to console service mesh. So console service mesh is just another layer of abstraction where all those the services or the containers that are deployed into the cluster can be identified by the load balancer internally, right? And the containers are already integrated with Vault, so all the secrets are read from HashiCorp Vault. So this is just a very high level view of how the build happens and also at the request phase, right? So the build system that we use, right? We created our own build system internally, right? So the first version of Brimble has its own build system. We drew some ideas from Railpack and Xpack, right? So the idea was that we noticed that for Railpack and Xpack, right, it pulls a lot of, let's say, unnecessary code just for you to run your application or just to build your image, right? So what we did was that it was most especially tailored to front end applications, right? We had to come up with a very efficient way, right, to be able to build front-end applications very, very, very quickly and efficiently, right? So that was the custom build system that we wrote. We also have other build systems, right? We use Railpack. We had some implementation with Paquito, right? But we later discarded Paquito when we discovered Railpack could actually do some of the things we wanted it to do. And we have the general Docker file builder where you just have a Docker file and we build your application straight from it. Yes. So this is the runner architecture. So the runner is basically what actually takes um, your code, bundles it into like the image and also runs it as a Docker container, right? So there are two ways you can send a request to the runner, right? Either via gRPC, right? You just send a remote procedural call, right, to the runner, or we use we send we dispatch messages from core. So core is the main API that is integrated with the dashboard where users can just interact with the platform, right? So we send a RabbitMQ message to the system, right, to the runner system. The runner picks all the necessary information, right, the project ID, the Git URL, and any other additional compute specification, right, and any other things that are needed for the build to run. So what happened is that we clone the repository, right? We build the repository, right, using any of the available runners, either Railpack, the Docker file builder, or using our own custom Docker builder, right? So after I build it, we check for failures, right? Let's say the application fails, we can send a RabbitMQ message back to core, right? Telling the user that, hey, your build has failed, right? And during the build process, we save the logs, right, to S3. So every of the logs that you have right now is saved to S3, right? So, and there's a CDN where we are just able to like get the log files from and everything, right? So right now, as I said earlier, we get a message from the events dispatcher, which is RabbitMQ, right? Then we dispatch the job. So after receiving it from RabbitMQ, we send a request to a queue, right? Another Redis-based queue, right? So this is what we just use to manage the life cycle of the job internally, right? While we use RabbitMQ just to receive messages from external sources, right? Then the build worker builds the image, gets secrets, and also we manage cache. So cases of when you want to redeploy your project, it's always going to be faster, right? So the cache is uploaded to S3. So the reason why we don't store the cache on the host machine, even if it's a bit faster, is because first of all, we can run out of storage very quickly, and data loss is like it might be very, very inevitable, right? So it's securely stored in S3. So we make a cache export, right, to S3 to actually export the cache. So when next you want to run a build, we pull the cache straight from S3. And the way we architected S3 to the runner is they are just close to the locations of where. So let's say, for example, we have a runner deployed in Europe, Germany precisely. So there's a S3 bucket, right, that resides around the region because of latency, right? So we don't want to have S3 buckets in America or the US region and the runner is in Europe, right? So to avoid that latency issue, every runner has its own S3 setup with it, right? Then after building the application as an image, right, we send it over to Nomad so that it can be able to deploy it to the cluster. So there are two phases to this thing. So the first phase is we temporarily build your project, right, as a container that needs to run. So the user can have their projects live and running. Then the second phase is when we take it to Nomad to now like perform the orchestration. Either you want to replicate your container, you want to add resource limitations, you want to auto scale your application, right? So the Nomad orchestration handle that process entirely. And for every build process, we acquire a lock. So the reason is because our runner is has like different replicas, right? So let's say in one instance or in one machine, we can have like three replicas of the runner. So any of the runners can actually pick the job, right? So the idea is when messages from core are sent to the runner, right? Because of we have three replicas or let's say n replicas of runners, right? And the way RabbitMQ is designed, is just one of the runner that is meant to pick that RabbitMQ message and process the job. But there are some cases where we notice that two of those runners were actually trying to like compete for the same build. So there could be situations where a single runner is running the build and another runner is also trying to run the build, right? So what we did was that there's a Redis layer, right, attached. There's a single Redis layer, right, attached to all the replicas of the runner, right? So let's say we have three runners, right, just talking to one local Redis instance, right? And all this, the communication is done via console connect. So everything is done securely and also internal. Like the Redis is not available outside, right? So we acquire a lock, right? So the idea of the lock is just to ensure that the build actually runs on one system, right? And on other replicas of that system is not going to be able to compete to actually run for the build. When the build is done, Nomad has a very tight integration with console. Like it's very very easy for you to connect console to Nomad. So what happens after the build has been done successfully? Nomad runs console runs a series of health checks, right, to the application, right, and console has a bunch of ways it can run health checks. So let's say your application is gRPC based, you can run health checks, right, for your gRPC application. If it's just a TCP connection, maybe you want to deploy a database or you are deploying a worker, right? If it's HTTP, maybe you have a health check route and you just want to check if your application is returning a 200, right? And the beautiful thing is that if your application doesn't respond with a 200 or giving like an expected response, right, it doesn't allow the build to pass. And we use a very popular deployment strategy. We use Canary, right? So there are cases where when you deploy your application, right, it would auto promote, right, to the working version, right? So it runs like a couple of checks. Let's say for 5 minutes, if it's satisfied after 5 minutes, it can move traffic like slowly to the other system, right? And when the traffic has been moved completely, it can delete the other instance, right? So all these things happen like in a very, very short period of time, and users won't even notice. And when Nomad is completed with the whole setup, the temporary container that we created for the user to be able to access the application is deleted. So we don't have cases of where we are running duplicate containers, right? Especially when the user did not specify that they want replicas, right? And for container security, right, we had an implementation in PaaS, right? We're using Firecracker to run isolation, right, for the system initially, but we are running into some performance overhead. Even though Firecracker was designed to be very light, right, on your system, uh, there wasn't really a very perfect integration with Nomad, right? It was inconsistent. It could work for specific types of application and it could not work for some type of applications, right? And because of the way Firecracker is designed, the isolation is done at the hardware level, right? While normally for Docker isolation, it's just done at the operating system level, right? So one of the things that we did was that we moved to gvisor. So gvisor is a container security runtime developed in-house by Google, right? So we integrated gvisor, right? So we can be able to run untrusted workload with on Brimble. So whatever you want to deploy, either anything good, anything bad, right? All those services are not really affected by each other, so they are independent. I think I'll move to the next one. Yeah, so our current cluster setup, so we actually run lean. So we scale based on the demand, right? Let's say we notice that we have a new bunch of like deployments, or let's say a new bunch of users that they want to deploy some things frequently. So our cluster runs in two regions as of now. We run in Europe and also in the US, right? Because we have some users that actually deploy some of their workloads to the US, right? Everything is connected through console Nomad, right? Right, and there's a proxy service that lies in every dedicated load balancer. So there's a request phase to how we manage requests for users, right? So there is from Cloudflare, right, to Caddy. So we use Caddy for reverse proxy. We don't use Nginx. So we were using Nginx initially, but we wanted to be very, very flexible with how we are managing like proxy for users. And the way Caddy is designed, you can easily like just decouple Caddy and you just pick what you want, build it, and you're like good to go. Compared to Nginx, where you still need to like learn Lua, right, and also setting up some funny configuration files. So we had to like move away from that and we moved straight to Caddy. And a very sweet benefit of Caddy is that it gives you auto SSL, right? So you don't need to manage certificates for your domains, right? So Caddy has something that just manages your SSL certificates for you automatically, right? It renews it, and all these things are connected to all these things are connected to Cloudflare already. So we run a console nomad server, right? Three console nomad server for consensus. So the way orchestration system works is that If you want to have proper consensus, right, they need to be a odd number, right? So let's say starting from three, five, seven. Seven is an overkill, but most cases is mostly for like three, five, right? So it's called the Raft consensus, where before, let's say if a server is down, some sort of election needs to happen between those servers, right? And because of you are running a odd number of servers, right? Two can always kick out one, meaning that you can always have two votes that can outkick the third one, right? So if you are running a even number of servers, right, you can run into a problem where election might not really be fulfilled, where let's say four of the servers can like vote for a new leader, and four of those servers can actually reject the election, right? So it's not always good to run your cluster with number of servers, right? So more servers, obviously means better fault tolerance, right? And if a cluster is down or if a particular machine is down, it can always replicate the workload to the other system, right? Yes. So how we currently manage multi-tenancy. So at the point of when a user signs up on Brimble and they want to deploy their first application, right? At the point of where they want to deploy their first application, we create a namespace for them, right? So Nomad has some similarities with Case where you can just create an isolated namespace for every user, right? And that namespace is just going to contain all the deployed application just pertaining to that user, right? So there's no a default namespace where everyone is just sharing namespaces, right? So let's say, for example, there's going to be Ileri namespace where all my applications are there, right? And there's a very like nice way of trying to restrict how you can manage traffic between these containers, right? Even if they are running in a bridge network, because there are different types of network. There's a bridge, there's a normal host network, right? So each of these applications run in a bridge network, which meaning their network is isolated, right? And there's a layer to it which console uses, which is called console connect. So console connect is a way you can securely connect two or more applications, right, deployed in your namespace so they can securely talk to each other, which uses mutual TLS. So things are very, very secure. So you don't just connect plainly. There's some sort of mutual TLS that actually happens between two of those services, right? And the console connect uses an Envoy sidecar, right? So there's Envoy that actually proxy the request, right, in between. Let's say, for example, you want to talk to your database, let's say from your API to your database, right? There's an Envoy sidecar, right, that serves as console connect, basically, that proxies the request from your application to the database. So these things are done securely, right? And Console has a concept called intentions. So intentions is just a bunch of rules where you can describe how you want to manage traffic, right, between two services. So let's say, for example, I want to be able to control how I'm communicating with my database, right? But I don't want to be able to communicate with maybe another service, right? So console intention is just a way for you to be able to manage rules on how you want to be able to connect to it, right? So if your application doesn't meet the criteria or the rules that you've already set out, it's going to cancel traffic. But by default, the way we do it is that all your applications in your namespace can communicate to each other because we don't know the requirements that users might want, right? So every applications in your namespaces can communicate to each other by default, but outside your namespace, it can't communicate to it. So we have an internal URL that like a private internal URL. So it just has your app name, then Bubble.internal, right? Console does all this heavy lifting for us, right? Yes. I think I already explained console intention, but I think I could read this out. We use console intentions to control service to service communication with a simple rule. Nothing connects to anything unless explicitly allowed. So by default, every app deployed by user has an intention, right? When a user's app needs to talk to their database, we create an intention allowing specific connections, right? All traffic go through mutual TLS automatically. So users app A can connect to another user's app B, right? Because there's no intention permitting it. So this gives some sort of zero trust networking, right? Without having to like manage firewall rules. And a very funny thing is that even if you want to manage maybe your firewall with UFW, right? UFW can't manage firewalls for containers. right? It's a very funny and tricky thing. So if you want to manage networking right with your container, you need to go to the IP table to do that manually, right? And things can get messy if you decide to mess around with your IP table. I don't advise like messing around with your IP table, right? So console intention manages how traffic is managed between two services. Uh, yes, so at the request phase, uh, I made references to this earlier, but I think I can extensively explain about talk about this rather. So we have Cloudflare that sits in front of everyone's application, right? Then it talks to the load balancer. The load balancer has CADI, right, at the default ports 80 and 443, right? So that is where CADI is running on. And we wrote our own custom proxy. So the reason is because we want to be able to manage how requests get into the user application. So let's say cases of when the user subscription is due. I know that's a bad thing, but like cases of when the user subscription is due, right? We can be able to override the web page telling the user that, oh, your subscription is due. Just like the web Vercel has this kind of thing where if you've not renewed your subscription after maybe I think 30 days, they display a custom message that overrides your application, right? Also, how we want to manage traffic between CADI and proxy. So the way we design the proxy is our proxy server runs on 3030, right? Uh, it's also deployed in the cluster, right? So we can have multiple replicas. This is just an example, right? We can have multiple replicas of the proxy server running, right? Deploying in the Nomad cluster. So the way it works is we first get settings. So the settings is just something that we use internally. So let's say cases of when we are running maintenance, right, in our system we have an in-house dashboard where we can just toggle maintenance on. So this already overrides the page telling the user that, oh, we are doing some sort of maintenance on our system. Please hold on for a few minutes, right? Then it moves to the gateway, then authentication. So authentication is just a layer where we just check if some things are done right, right? Then when you're making a request to the application, if your application is a static site, we just proxy the request to S3, right? So say cases of when when you want to deploy HTML projects, maybe Vite, you built your Vite application as a static site, maybe React, right? So all these are uploaded to S3. We don't treat them as a container because treating it as a container is just unnecessary resource overhead, right? So we just upload those files to a S3 bucket, right? But if it's not a static site, we go through a proxy, right? Fast proxy like so. This is a our proxy. We wrote our proxy in TypeScript actually, right? So for static sites, the request just moves to the S3 bucket, right? And we usually check if the site is valid, right? Because there's a Redis attached to every proxy. That Redis is synced in real time with our database. So there's a local Redis instance, right, on every proxy, right, and that Redis instance is always like synced to our database. So for this case, we use MongoDB, and MongoDB has something called a model watcher, right? So the idea of the model watcher is just for you to watch for changes that happen in your DB. So let's say anytime an insert operation happens, a delete operation happens, right? What we do is that whenever this operation happens, we invalidate the cache so we don't have a couple of stale data. So let's say cases of when you deployed V1, right? And let's say you deployed V2, right? System version is V1, right? So cases of when a user wants to deploy and they make a new request, right? We don't want them to see V1, right? We want them to see V2. So we usually clear that cache, right? Then at the request level, everything is to console service discovery, then the cluster. I think it's almost time for question. I think I've explained the Cloudflare request phase, right? We have load balancers in two major regions. Actually, we have in Europe and we have in US. So what we use Cloudflare in front of them is, let's say cases of we route traffic based on your location, right? So there's a regional load balancer that Cloudflare provides. So cases of when you're in the US, right? Obviously, you don't want to send requests to the load balancer in Europe, right? It's going to go through the one in the US, right? And extreme cases of when a load balancer is down, everything routes to the readily available load balancer, irrespective of your region. So that's like the beauty of using Cloudflare at the request phase. Some significant challenges. we actually built our own custom DNS server. So there's a DNS server at ns1.brimble.io and ns2.brimble.io. Uh, our custom Docker builder, we actually wrote our own builder like Wheelpack, right? Very soon I might open source it. It's not open sourced at the moment, so we are looking to having like a bit more contributions to it in the nearest future. Also our proxy. I think because of time, I might just have to like skim through some things. Yeah. Okay, so what we expect in the future, Brimble might roll out S3 buckets very, very soon. So your S3, your normal S3 buckets. Also the Brimble marketplace and project groups, ability to group projects. Let's say you are working on a particular product, you can be able to have that product have like a bunch of projects, right? Just basically improving the UX actually. Yes, I would like to show a demo, but I think because of time, yeah. Thank you very much. So this is just how I do my little things at Brimble. Thank you, everyone. Yep.
Awesome. Thank you
Yeah.
so much, Ileri. That was amazing, honestly. So,
Yeah.
luckily, we have just two questions. We can probably
Okay.
take that before time is up. The first one, um, is there any plan to have a serverless function support?
So firstly, no, not yet, because I'm not really a big fan of serverless. Uh, but it depends on the demand that we get from users. So if users are currently requesting for serverless, obviously we can always roll out serverless features. But right now, because we're trying to like manage how we're sharing out resources, right? We don't have serverless support yet. Yes.
Cool. Thanks. So the next one, how do you handle container orchestration and self remediation?
Uh, Nomad pretty much handles the orchestration process, right? You want to auto scale your container, you want to deploy in different regions, you want to be able to selfie your application. So let's say your application crashes, it automatically restarts, or it takes it to another instance, or it can just reschedule the job into a different instance. Um, I don't know if I answered your question well. I don't know, but yeah, Nomad handles the orchestration actually. Yeah.
Yeah, I think that works. Last one, is Nomad like Kubernetes?
Yeah, it's like Kubernetes. So it's a very growing technology now. Right now, I think it has around maybe 25K stars on GitHub right now. So most of the tools in HashiCorp, like the HashiCorp ecosystem, right, they use Nomad. Um, it's not as popular as Kubernetes, right? Kubernetes has like lots more support, but they technically do the same thing. Yeah, it's they have the same thing, but Nomad is way lighter than K8. K8 has everything in the box, but Nomad is just a single binary. Then you can decide to plug in other services like your HashiCorp Vault, Console Suite, right? If the need be. Yeah,
Awesome. So thank you so much.
yeah.
If anyone has any more questions, you can drop it in the chat. Um, Amazingly, we are going to be having Ileri soon on our podcast, so we
Okay.
can pick up from where we stopped here. Awesome. All
I
right.
think there's the last question. I don't know if there's time to
Oh, okay.
answer.
There's one more. Okay. Time's up. But does the static site you upload to S3 use Cloudflare or CloudFront as a CDN?
Yeah, we use Cloudflare as CDN. So we just upload it. We don't use cloud. We are not dependent on AWS. So the time that AWS were down, EUS were down, we're not affected. So we run a multi-cloud setup, right? So today I could say I want to deploy something to EC2, or tomorrow I can have something on X now. So we're not dependent on AWS. So we don't use CloudFront. We use Cloudflare.
Awesome. Okay.
Yeah.
All right. That's it, guys. Thank you so much.